For this video and others like it, every single question will go through the same 6 steps. 1. State the question. 2. Give the correct answer with a oversimplistic explanation. 3. Explain the answer with an analogy. 4. Give an in-depth technical explanation for what the answer is and why it is the correct answer. 5. Explain why the other answers are not correct. And 6. Give a real-world example or scenario.
The network administrator is looking at an ARP table on a switch for connected devices. Which Open Systems Interconnection OSI layer are they looking at? Choices: network, physical, session, data link. Correct answer: data link layer. The ARP address resolution protocol table maps IP addresses to MAC addresses and MAC addresses live at the data link layer, layer 2. 3. Analogy. Think of mailing a package. The IP address network layer is like the street address. The MAC address data link layer is like the exact person's name on the mailbox. An ARP table is basically the neighborhood who lives at which house list, tying the street address to the specific resident. For in-depth technical explanation, ARP address resolution protocol works between layer 2 data link and layer 3 network. At layer 3, devices only know IP addresses. At layer 2, the actual delivery on a LAN requires MAC addresses. The ARP table on a switch shows mappings like 192.168.1, point 10, 000, 1A, 2 billions, 3C, 4D, 5E. This is stored in memory, so the switch knows which MAC address corresponds to which IP. While ARP is technically a layer 2 protocol, it's often said to be a layer 2.5% protocol, since it bridges IP layer 3 and MAC layer 2. 5. Why the other answers are wrong. Network layer 3 deals with IP addresses and routing, not MAC address mappings. You'd be looking at a routing table here, not an ARP table. Physical layer 1 deals with bits, voltage, cables, no concept of addresses. Session layer 5 manages connections between applications. ARP is way lower level than this. 6. Real-world example scenario: when your computer wants to send data to 192.168.1.5, it checks its ARP table to see which MAC address belongs to that IP. If it doesn't know, it broadcasts an ARP request, who has 100. And 92.168.1.5? The device responds with its MAC address, and now traffic can flow directly on the LAN. On a switch, the ARP table is how the device knows which port to forward frames to, based on the MAC address. An organization has asked a network administrator to research and submit a purchase order for new network access points. The network administrator is attempting to choose between using wired and wireless access points. Which layer of the OSI model is the administrator making a decision? Choices: session layer, data link layer, network layer, physical layer 2. Correct answer, with oversimplified explanation. Correct answer: physical layer, because the choice is about how the signal travels wired equal to copper, fiber, wireless equal to radio waves. This is the physical layer, layer 1. 3. Analogy. Think about delivering a message. Physical layer is the method of delivery. You send it by walking, by car, or by drone. The message itself doesn't change, but the way it gets from sender to receiver depends on the chosen medium. In this case, wired equal to cable, wireless equal to airwaves. 4. In-depth technical explanation. The physical layer, layer 1, defines the hardware transmission medium and signaling methods. Wired uses copper, Ethernet cables, or fiber optics to transmit data as electrical pulses or light. Wireless uses radio frequency signals to transmit data through the air. Access points operate at higher layers too, but the administrator's choice here is about the medium of transmission. That makes it a layer 1 physical decision. 5. Why the other answers are wrong. Session layer, layer 5, manages conversations between applications start, maintain, end, not related to hardware decisions. Data link layer, layer 2, handles MAC addresses and framing. Important once the medium is chosen, but not the decision point here. Network layer, layer 3, handles IP addressing and routing. Again, doesn't decide whether data travels by copper or RF. 6. Real-world example scenario. When setting up a new office, the admin may ask, do we run Ethernet cables to each workstation, wired, faster, more reliable, or do we install Wi-Fi access points, wireless, more flexible, less expensive to expand? That choice is a physical layer design decision. It determines how bits actually travel. What is the role of an access control list ACL at layer 3 network layer of the OSI model? Choices: to define the maximum size for packets transmitted across the network, to serve as a list of permissions for file access on the network, to act as a routing protocol for determining the best path for data packets, to filter network traffic by permitting or blocking packets based on IP addresses and other criteria. To correct answer with oversimplified explanation. Correct answer: to filter network traffic by permitting or blocking packets based on IP addresses and other criteria. At layer 3, ACLs decide which traffic gets through and which traffic is blocked. 3. Analogy. Think of a bouncer at a nightclub. The ACL is the list of rules the bouncer uses. People over 21 only. No one wearing flip-flops. VIPs get in automatically. The bouncer doesn't care where you go inside once you're allowed, just whether you get in or not. 4. In-depth technical explanation. An access control list ACL at layer 3 network layer filters traffic based on IP addresses, protocols, or port numbers, is applied on routers or layer 3 switches to control ingress incoming and egress outgoing traffic, can enforce security policies, for example, block certain subnets, allow only specific servers. Example rules: permit traffic from 192.100 and 68.1.0, 24 to the web server, deny all traffic from 10.0.0.08. Allow only TCP port 443 HTTPS. This operates directly on the packet headers, which live at layer 3. 5. Why the other answers are wrong. Define the maximum size for packets transmitted across the network. That's related to MTU, maximum transmission unit, not ACLs. Serve as a list of permissions for file access on the network. That's a file system ACL at the OS level, not a network ACL. Act as a routing protocol for determining the best path. That's done by protocols like OSPF, RIP, BGP, not ACLs. 6. Real-world example scenario in a company network. The HR department's subnet, 192.160. 8.50.0. 24. Needs access to payroll servers. The ACL is configured on the router to allow HR subnet traffic to the payroll server but deny all other departments. So when traffic hits the router, the ACL checks the rules and either lets it through or drops it. Which Open Systems Interconnection OSI layer assumes responsibility for managing network connections between applications? Choices: physical network data link session. Two. Correct answer with oversimplified explanation. Correct answer: session layer. The session layer manages, maintains, and ends communication sessions between applications. 3. Analogy. Think of a Zoom call. The session layer is the moderator who says, "The meeting is starting now. Please stay on mute until it's your turn. The meeting is over. Goodbye." It's not carrying the video audio itself. It's organizing the session of communication. 4. In-depth technical explanation. The session layer, layer 5, handles establishing connections between applications, managing dialogue control, deciding who talks when, synchronization checkpoints during large data transfers so progress isn't lost, gracefully terminating connections. Protocols operating at this layer include NetBIOS, RPC, Remote Procedure Call, and PPTP. Without it, applications would send data, but they wouldn't know how to coordinate when to start, pause, or stop communicating. 5. Why the other answers are wrong. Physical layer 1 handles cables, signals, and bits on the wire, not sessions. Network layer 3 handles logical addressing, IP, and routing, not application sessions. Data link layer 2 deals with frames and MAC addresses, no concept of sessions. 6. Real-world example scenario when you use remote desktop protocol, RDP. The session layer manages the session between your PC and the remote computer. It makes sure the connection is properly started, keeps it alive, and closes it cleanly when you log off. Character encoding, data compression, and encryption, decryption take place at which OSI layer? Choices: application layer, session layer, transport layer, presentation layer. Correct answer with oversimplified explanation. Correct answer: presentation layer. The presentation layer makes data presentable. It formats, compresses, and secures data so applications can understand it. 3. Analogy. Think of an interpreter at the United Nations. The interpreter doesn't change the message itself. They make sure it in the right language and format so the listener understands it. That's what the presentation layer does. It encodes, compresses, and encrypts the data so applications can communicate properly. 4. In-depth technical explanation. The presentation layer, layer 6, is the translator of the OSI model. Its main responsibilities: character encoding, ASCII, EBCDIC, Unicode, etc., data compression, reducing file size for transmission, for example, JPEG, MP3, encryption, decryption, making data secure, for example, SSL, TLS at this layer conceptually. This ensures the application layer, layer 7, receives data in a format it can use. 5. Why the other answers are wrong. Application layer, layer 7, provides the interface for end users, for example, web browsers, email clients. It uses the formatted data but doesn't handle the encoding or encryption itself. Session layer, layer 5, manages sessions, conversations, and synchronization, not responsible for data formatting. Transport layer, layer 4, ensures reliable delivery, TCP, UDP, error checking, and flow control, not presentation. 6. Real-world example scenario. When you visit a secure website, HTTPS, presentation layer handles SSL, TLS encryption so your data is safe. It also ensures characters are properly encoded, UTF-8 for text. Data might be compressed, gzip, before transmission. Without the presentation layer, applications would get raw, unreadable data. This one's a multi-select. Let's go carefully. 1. State the question. Which of the following functions are performed by the OSI transport layer? Select 3. Choices: reliable message delivery, consistent data formatting, between dissimilar systems data segmentation, and reassembly, end-to-end flow control. 2. Correct answer with oversimplified explanation. Correct answers: reliable message delivery, data segmentation, and reassembly, end-to-end flow control. Not correct: consistent data formatting. That's the presentation layer's job. 3. Analogy. Think of sending a big box of Lego sets through the mail. The transport layer makes sure the sets are broken into smaller boxes. Segmentation, labeled, and reassembled correctly when they arrive. It ensures all boxes arrive safely, reliable delivery. It paces the shipment so the receiver isn't overwhelmed, flow control. But it doesn't care about what the Lego pieces look like. That's formatting, which belongs to the presentation layer. 4. In-depth technical explanation. The transport layer, layer 4, provides reliable delivery, ensures data gets from source to destination without errors, TCP acknowledgements, retransmissions. Segmentation and reassembly breaks down large data streams into smaller chunks, segments, then reassembles them in order at the destination. Flow control manages how much data is sent at once, so the receiver isn't overwhelmed, TCP sliding window. This layer is all about ensuring complete, correct, and orderly delivery of data between end systems. Protocols: TCP reliable, UDP unreliable but faster. 5. Why the other answer is wrong. Consistent data formatting between dissimilar systems. That's the presentation layer. Layer 6 responsibility: handling character encoding, compression, and encryption. The transport layer doesn't care about the format of the data, only that it arrives reliably. 6. Real-world example. Scenario: when you stream a file download, transport layer, TCP, breaks the file into segments, sends them, ensures they arrive intact, and reassembles them in the correct order. If any segment is missing, TCP requests it again. Flow control prevents flooding your computer with too much data at once. Without the transport layer's reliability, you might end up with missing or jumbled file pieces. Which of the following protocols reside at the application layer of the Open Systems Interconnection OSI model? Select 2. Choices: IP, TCP, HTTP, SMTP. Correct answer with oversimplified explanation. Correct answers: HTTP and SMTP both are application layer protocols that directly support user-facing services, web browsing, email. 3. Analogy. Think of a restaurant, HTTP equal to the waiter bringing you the menu and your order, web browsing. SMTP equal to the delivery driver taking letters to the post office, email. TCP equal to the road system that makes sure cars drive safely to the restaurant. IP equal to the GPS, addresses that tell drivers where to go. The application layer is all about the actual services people interact with, in this case, web and email. 4. In-depth technical explanation. HTTP, Hypertext Transfer Protocol, used by web browser servers for transferring web content, lives at layer 7. SMTP, Simple Mail Transfer Protocol, used to send email between servers and clients, also layer 7. By contrast, IP, Internet Protocol, Network Layer, layer 3, responsible for addressing and routing packets. TCP, Transmission Control Protocol, Transport Layer, layer 4, responsible for reliable delivery of data. So only HTTP and SMTP reside at the application layer. 5. Why the other answers are wrong. IP handles addressing, routing at layer 3, not application level. TCP provides reliable delivery at layer 4, not application level. 6. Real-world example scenario. When you open a browser and type in www.example.com, HTTP gets the web page for you. Send an email, SMTP is what actually moves that message from your email client to the mail server. Neither TCP nor IP directly provides those services. They just make sure the messages can travel reliably across the network.